right, so this mini lecture is going to look at the idea of pressure. So I want you to imagine that you're at a fancy wedding at a country club, and the bride is wearing a beautiful stiletto heel shoe, and she's getting ready to walk out onto the grounds to take some photos. And you realize, wait a minute, what's going to happen as soon as she walks out onto that ground, that nice soft grass at the country club? Well, she's likely going to sink, right? So we've all maybe seen or heard or witnessed somebody who's walking maybe in a heeled shoe on soft ground, and the heel buries. Whereas you notice her partner that she's marrying is in a more chunky heel. And as that person walks out onto the ground, let's say they're the exact same size, and that person walks onto the ground and the mass is no different, the force is no different, but they don't sink. So why is it that this clunky heel, this big heel, doesn't sink into the ground, but the stiletto heel does? Well, the idea is about pressure. So remember, both of these two individuals had the same mass. Therefore, their weight was the same. Therefore, the force of gravity was the same. So the downward force that these individuals are acting on the earth, if we look at from a sort of the macroscopic, the force, the center of mass model, well, they're the same, yet very different interactions are happening at the surface, and that has to do with pressure. So what's the difference between these two heels? Well, the amount of space that's actually interacting with the ground is different. It's different in terms of its area. So as I increase the area, well, there's less of a problem. There's less what we call pressure. So as I increase the area, I decrease the pressure that's acting on the ground. Conversely, if I decrease the area, as in the case of the stiletto heel, I increase the pressure. All right, so pressure is related to the area that's interacting. Well, what else might be important? Let's imagine that you catch the bride in time and you say, oh, don't wear your shoes, put on these tennis shoes. And so she puts on the tennis shoes, and her and her partner happily walk away. Well, then that young flower boy or girl is seeing these fun shoes to walk in. So what do? They quickly grab them, pop them on their feet, and tromp along the grass. Interestingly, they don't sink. This small child doesn't sink. Well, what's different here? Well, the small child has less mass than the adult, and therefore there's less force of gravity acting on the shoe, and therefore there's less force of gravity acting on that small area. So if I decrease the force that's acting on that space, well, I don't have as much of a problem. I decrease the pressure. And these ideas lead to our formula for pressure in a similar way that we've dealt with making relationships throughout the semester. Pressure is equal to the force over the area that force is acting. And so, very straightforward relationship and pretty easy to calculate. But it's going to help us identify some principles in our fluid discussion as well as we move through the ideas of fluid statics and fluid dynamics. So pressure is simply relates the force to the area that force is applying. Good job.